Good morning, everyone. Today we're going to learn about atomic emission spectra. What you see on the screen are different neon lights. Neon lighting consists of brightly colored gas tubes or bulbs that contain neon or other types of gases. Neon lights were named for neon, a noble gas which gives off this popular bright orange light. But other gases and chemicals are used to produce other colors, such as hydrogen produces this bright red color, helium produces this yellow color, carbon dioxide is this white color here, and this blue color is produced by mercury. So let's look at this image. This is an image of a neon light. The neon gas is filled in a gas tube, and the gas tube is subjected to a high voltage source. When that happens, this neon gas can emit out bright orange light. Okay. So let's look at these two images here. We're going to start with this image. In this image, we have a white light, and when we take the white light and pass it through a prism, we know that the light would bend and we can see the different colors of the rainbow like this. The white light getting separated into different colors. This happens because each color has a particular wavelength and each wavelength bends at a different angle. So, what we see is this continuous spectrum where the colors are blending into each other. A rainbow of colors, and each color blends into the other color. Okay, now let's look at this image here, and we see a neon light. When we pass a neon light through a prism, we do not see a continuous spectrum. Instead, what we see are these distinct lines. If you can see here, distinct lines. Compare it to this one. This here is a continuous spectrum. This is atomic emission spectrum. Okay, and we can get atomic emission spectrum by heating an element which can give off color and passing that color through a prism. Okay, the wavelength of spectral lines are characteristic of the element, and together they make up the atomic emission spectrum. No two elements have the same atomic emission spectrum. So these emission spectrums or spectra act as fingerprints of an element. We can identify an element based on the atomic emission spectrum. And this is where let's look at the different atomic emission spectra which are coming from different elements here. We have sodium, hydrogen, calcium, and mercury. And if you look closely, each element has specific distinct lines. No two elements have the same set of lines. Okay, so when heated or subjected to high voltage source, atoms absorb the energy and their electrons move to a higher energy level. Now, these electrons, they cannot stay at that higher energy level for a long time. They come back to their ground state, to the state that they were earlier by giving off light. So, electrons which have absorbed energy, they can lose that energy by emitting light. And that's what we have been seeing here. Okay? So electrons are taking in energy from the electrical source and they are getting excited. They move to a higher energy level. They have absorbed that energy and they have moved to a higher energy level. And when they come back to their actual energy level, they give off the absorbed energy as light. And that's what we see here. Each element giving off a very specific colored light. Okay, the same thing. These are different atomic emission spectra of different elements. Okay, so on this slide, we are going to look at two different vocabulary words. The first one is ground state. What do we mean by ground state? Well, this is the energy level where electrons start from. This is the lowest energy level. This is where the electrons are present around the nucleus in their ground state. But when heat or electricity or light is provided to these electrons, they can absorb that energy and they can move to a higher energy level. In this state, the electron is said to be excited. Okay, so there are two vocabulary terms that you should be aware of. Ground state, and this is the lowest energy level. That's where the electrons are present around the nucleus in their lowest energy level. But when electrons are provided with energy, they can absorb energy either through heat or through electricity or when light shines on it. They move to a higher energy level, and that is now known as excited state. Electrons are in the excited state. Okay. So when electrons fall back to the ground state, the electrons give off the energy that they have absorbed as light or photons. Okay, and that's what you are seeing in this picture also, that electrons, when they move from higher energy level to the lower energy level, they give off light. Okay, so atomic emission spectra are unique spectra of light emitted by an element when heat or electricity is run through it or when it is viewed through a prism. They are very unique and they act as an element's fingerprint. And we can identify an element based on its atomic emission spectra. That's it for today, guys, and we will regroup for the next lesson. Have a good day. If you have any questions, feel free to email me and I will get back to you as soon as possible.